Hi, this is a supplementary math lesson for Algebra 2, covering lesson 76B, negative vectors. So we're going to be adding two vectors, and we won't actually get into probably splitting them apart and recombining them into polar form. If you need to review that, go to lesson 63 from Monday to review that. Just want to focus on handling negative vectors. We know from our last lesson 72B how to deal with negative angles. So here we're going to be adding two vectors, a -4 at an angle of -20 plus 5 at an angle of 135. Okay, so let's look at this first vector here. Okay, and again, everything starts from the origin. And so what do we have? We have a length of -4. What does that mean? I haven't seen that before. At an angle of -20. Well, we know what the angle of -20 means, okay? Normal convention is to measure angles counterclockwise from the x-axis here. For negative angles, we simply measure them clockwise. Oops, that's a negative. Okay, so it's going to be 20 degrees in the negative direction, somewhere along here. Okay, but now we don't have a length of 4 out from the origin. What do we have? We have -4. What is -4 compared to 4? It is the opposite direction. If we have a number line, this is our origin. If this is +4, where does -4 lie? It lies 180 degrees opposite on the number line, but the same distance away from the origin, -4 units. It's the same concept with vectors. That -4 will lie the total opposite 180 degree direction, but -4 units, the same number of units, 4 units away from the origin, okay? Because they reference the minus angle, but it's a minus distance along that line. So it's actually on the opposite side of the line they reference. And I know that's a little confusing, but that's the way it is. And so what do we do there? Okay, this was a -20 degrees. Okay, we have vertical angles here, so this is 20 degrees. Okay, we complete our reference triangle back to the x-axis. Okay, so to break this apart then, to find our right-left component and our up and down component, again, our right component is going to be the hypotenuse times the cosine of 20, and our up-down component is going to be the hypotenuse times the sine of 20. Okay, and I'm not going to do the math on those, the book within, and we're going to combine those into now polar coordinates. And so we're going to have in our component the number in the r direction is going to be negative because it goes to the left, and the number in the u direction is going to be positive number in the u direction. Okay, so if we look at this, we said before, okay, when we have a vector here of -4 at an angle of -20, we can also express that as an angle -4 at an angle of what? Okay, at an angle of all the way around 360 degrees except the last 20, an angle of 340 degrees. Okay, so if we express that at 340, the line still lies here, but we plot out the opposite distance on the other side of the axis. Okay, similarly, we can use a +4 and come around this way. 90 plus 70, 160 degrees. Okay, 160 degrees will be this line, and then we plot a positive 4 along there. It's the same vector. Or if we use a positive 4, we could come along the negative direction, minus 90, minus 180, minus 200. Okay, we come around minus 200, it gives us this line. And then we plot out plus 4 along that line. So we notice in polar coordinates, we have 4 separate ways we can express the same vector. Last lesson we said we had 2 ways. We actually have 4 ways. Okay, we can plot the negative distance with either a positive or negative angle, or we can plot the positive distance with a positive or negative angle. Okay, so whatever they give you, just draw it, and draw the proper angle going around positive direction or negative direction, and then make sure, am I plotting? If I'm plotting on the same side my line is drawn, it would be a positive number. Okay, if that number is negative, I have to go on the opposite side, the 180 degree opposite on the graph to get the proper vector. Okay, so from there, what are we doing then? That these here simply split apart this vector into its up and down and left and right components. We do the same thing here. Okay, we split that apart, and we notice, what do we have? Well, we have a positive angle of 135, so we have 90 plus another 45 gives me an angle out here, and it's a plus 5. Okay, it's a plus 5, so I plot the distance on the same line that I referenced, and I make my reference triangle back to the x-axis. And then what is my reference angle? My reference angle is right here, back to the x-coordinate, here in the orange. Okay, that angle is 45 degrees. Okay, so to find my r component, okay, I take my hypotenuse times the cosine of 45. To find my u component, I take my hypotenuse times the sine of 45. Okay, then I look at those. Okay, what is going to be negative and what is going to be positive? My r component heading to the left, this is going to be a negative number. Okay, my u component goes up, it's going to be a positive number. Then I simply combine, I add this r and this r, this u and this u. Okay, and then of course, just like in lesson 63, I combine them back together to get a polar coordinate. I'm not going to do that. I just wanted to handle the negative distance. The negative angles are a combination of the two in this one. If you need help adding vectors, refer back to lesson video 63 from Monday. Okay, so I hope that helps. Shoot an email or a text message with any questions. Bye for now.